Hi everyone, today we are going to be looking at word problems involving right angle trigonometry. So go ahead and grab a piece of paper and pencil and let's get started. So the first thing we need to do is we need to talk about some terminology. So often in word problems you'll hear angle of depression and angle of elevation. So basically what this means is from the horizontal, either you're looking up at an object or you're looking down at an object. So if you're looking up at an object, that's the angle of elevation. And if you're looking down at an object, that's the angle of depression. So the angle of elevation is the angle from the horizontal to your line of sight. For example, you are looking upwards at an object. The angle of depression is the angle from the horizontal to your line of sight. This time you're looking downwards at the object. Okay, let's go ahead and look at our first example. So for this example, we are going to be solving for x. So you'll notice that the angle 47 degrees is outside of the triangle that we need to use our trigonometry with. So we need to determine how can we find the angle inside the triangle if we're given the 47 degrees on the outside. So you'll notice there is also a right angle symbol up in that top corner. So that means theta plus 47 is equal to 90 degrees. So we are going to subtract 90 from 47 and we're going to get our missing angle theta. Okay, go ahead and do that. So theta is equal to 90 degrees minus 47 degrees, so theta equals 43 degrees. Okay, so now we're going to use our right angle trigonometry to solve for x. So remember, labeling our triangles, x is across from the theta, so that's the opposite. And the 270 is adjacent because it's touching that perspective angle. So thinking about our trigonometry acronym, SOH-CAH-TOA, we are going to be using tangent. So we have the opposite over adjacent, so again we're going to be using tangent. So let's go ahead and substitute in the information that we know. So tan 43 degrees equals x over 270. Okay, so you'll notice our x is in the numerator, so we're just going to move the 270 in front of the tan 43. So 270 times tan 43 is equal to x. Okay, go ahead and plug that into your calculator, and we're going to round to 1 decimal. Okay, so you should have 251.8 centimeters. Okay, let's look at another example. If your distance from the foot of the tower is 20 meters and the angle of elevation to the top of the tower is 40 degrees, find the height of the tower. So the first thing we need to do is make a sketch of what we think the question is asking us. Okay, so please grab your ruler and let's make a nice diagram. Okay, so because we're still talking about right angle trigonometry, we know that we should draw a right angle triangle. Okay, so let's label the information that we know on our triangle. So the question says, if your distance from the foot of the tower is 20 meters and the angle of elevation to the top of the tower is 40 degrees, find the height of the tower. So the height of our triangle is going to be our tower. So let's go ahead and label the tower. And we are going to be standing at the bottom, kind of looking up at the tower. So I'm just going to draw a little stick person. So that's our perspective angle where the 40 degrees goes. And we also know that we are standing 20 meters from the base of the tower. So we can also label that on the bottom of our triangle. So the tower is going to be labeled with X because that's what we're looking for. We're looking for the height of the tower. So in this example, we have the adjacent of 20 and the X is an opposite. So again, if we look at our SOH-CAH-TOA acronym, we're going to be using tangent again. So again, I know that we're going to be using tangent because we have the X in the opposite position and the 20 meters in the adjacent position. So we're going to be using the tangent ratio. So tan 40 degrees is equal to X over 20. Okay, so we're going to notice that our X is in the numerator, so we're going to multiply by 20, move that next to the tan 40. So 20 times tan 40 equals X. Okay, go ahead and plug this into your calculator, and we're going to round to 1 decimal point. So X is equal to 16.8 meters. So for good communication, we should add a therefore statement. So therefore, the height of the tower is 16.8 meters. Okay, let's go ahead and look at another example. The angle of depression from the top of a castle to a boat is 25 degrees. If the boat is 350 meters from the base of the castle, how tall is the castle to the nearest meter? Okay, so I have a little diagram here off to the side. There's a castle on the cliff. There's a ship kind of in the water. So we're going to draw a triangle to kind of model this question. Okay, go ahead and grab your ruler. Okay, so I've added in my lines to make my right triangle. Put a little right angle symbol down the bottom corner. Okay, so let's go ahead and label the information that we know. So the angle of depression from the top of the castle to the boat is 25 degrees. So if I kind of imagine the horizontal line there, that angle inside the horizontal to the triangle is the 25 degrees. So we need to figure out the angle that's inside the triangle. So that's a 90-degree angle up top there in total. So 90 subtract 25 degrees will give us what's left in the triangle. So go ahead and make that calculation. Okay, so you should have the measure of 65 degrees inside your triangle. Okay, so the other piece of information that we're going to add to the diagram is that the boat is 350 meters from the base of the castle. So at the bottom I can add in 350 meters. So we need to figure out the height of our castle, or in other words, X. So if I look at the angle up at the top, so 350 is opposite, and the X is the adjacent. So again, it looks like we're using tangent. So tan 65 degrees equals 350 over X. Okay, so the X is in the denominator, so we're going to go ahead and swap tan 65 with our X. Okay, go ahead and plug that in on your calculators. So 350 divided by tan 65. Some of you will have to enter 350 divided by 65 tan. Go ahead. The nearest meter, we should have 163 meters. And because this is a word problem, we should have a therefore statement. So therefore, the castle is 163 meters tall. Okay, let's go ahead and look at another example. The stringer that supports the stairs makes an angle of 50 degrees with the floor. It reaches 3.2 meters up the wall. How far is the base of the stringer from the wall? So the picture on the right-hand side shows what a stringer is. It's basically a part of your staircase. So we're going to go ahead and make a right triangle out of this. So please use a ruler. And we're going to put the 50 degrees between the bottom of that stringer and the floor. So 50 degrees. And it reaches 3.2 meters up the wall. So 3.2 meters. And we're trying to figure out how far is the base of the stringer from the wall. So the X is going to go on the bottom there. So looking at the information we have an opposite and we're looking for the adjacent. So again, we're going to be using our tangent ratio. So tan 50 degrees equals 3.2 divided by X. So again, you'll notice that X is in the denominator, so we're going to go ahead and swap our tan 50 with our X. Okay, so go ahead and plug in your calculator, 3.2 divided by tan 50. And we're going to round to 1 decimal point. Go ahead. Okay, so the value for X is 2.7 meters. Okay, last but not least, we need a concluding statement. So therefore, the stringer is 2.7 meters from the base of the wall. Okay, let's go ahead and look at another example. A ship is 130 meters away from the center of a barrier that measures 180 meters from end to end. What is the minimum angle that the boat must be turned to avoid hitting the barrier? So let's go ahead and draw a diagram so that we can kind of imagine what the question is asking. Okay, go ahead and grab your ruler. Okay, so this is my barrier, so I'm going to go ahead and label it. And my boat is somewhere to the left, or I guess it could be to the right. I'm going to draw mine to the left. There's my little boat. Sorry, I'm not really an artist. Okay, I just drew a line through the middle to show that the boat is in the middle of the barrier. So I'm then going to add 2 lines to make 2 triangles. Okay, next I'm going to label everything that I know given the information in the word problem. So a ship is 130 meters away from the center of the barrier. So I'm going to put that 130 right in the middle. Next, I know that the barrier is 180 meters from end to end. So to figure out what the minimum angle the boat must be turned to avoid hitting the barrier, I'm going to put my theta down in the corner here by the boat. And then if all the way across the barrier is 180 meters, halfway is 90. So I'm going to draw that 90 on as well. So looking at the information that I have, it looks like, again, I have an opposite and an adjacent. So tan theta is equal to 90 over 130. So to calculate the missing angle, we're going to take the inverse tan function. So we're going to write this as theta is equal to tan to the exponent -1, or tan inverse, times 90 divided by 130. Okay, let's go ahead and plug that into the calculator, and we're going to round to the nearest whole number. Go ahead. Okay, so the measure for theta equals 35 degrees approximately. So we need a concluding statement. So therefore, the minimum angle that the boat must be turned to avoid hitting the barrier is 35 degrees. A ramp has an angle of inclination of 20 degrees. It has a vertical height of 1.8 meters. What is the length L in meters of the ramp? Okay, so go ahead and grab your ruler, and we're going to draw a diagram to help us imagine what this question is asking. Okay, so here's my ramp. I'm going to go ahead and draw in a 90-degree angle. And then we're going to label everything that we know given the problem. Okay, so the angle of inclination is 20 degrees. So I'm going to put that down in the corner. It has a vertical height of 1.8 meters. And we need to find the length of the ramp. So that's the hypotenuse, is the ramp. So that's what we're looking for. That's x. So looking at this example, we have an opposite and a hypotenuse. So let's take a look at our acronym. Okay, so we have an O and an H. So that means we're going to be using the sine ratio. So sine 20 degrees equals 1.8 divided by x. So you'll notice that x is in the denominator, and we're going to go ahead and swap sine 20 and x. Okay, go ahead and type in your calculator 1.8 divided by sine 20, or again, some of you may have to enter 1.8 divided by 20 sine. Okay, so the length in meters is 5 meters. If you rounded to 1 decimal point, it would be 5.3. We'll say 5 meters. Okay, finally, we just need a concluding statement. So therefore, the length of the ramp is 5 meters. Okay, we have one last example. Two students want to determine the heights of two buildings. They stand on the roof of the shorter building. The students use a clinometer to measure the angle of elevation to the top of the taller building. The angle is 44 degrees. From the same position, the students measure the angle of depression of the base of the taller building. The angle is 53 degrees. The students then measure the horizontal distance between the two buildings. The distance is 18 meters. How tall is each building? Okay, so let's go ahead and grab our ruler, and we're going to make a sketch so that we can visualize this word problem. Okay, so here are my two buildings, and I've drawn a line in between the both of them so that we can write on 18 meters there. Go ahead and draw your diagram. Okay, so the two students are standing on top of the shorter building. So I'm going to go ahead and draw a line because they're looking up at the roof of the taller building. And they're also looking at the floor or the bottom of the taller building as well. So I'm going to draw in a second line going down to the bottom of the taller building. I'm also going to draw a line in the middle because that's kind of where the students are. So the two students want to determine the heights of two buildings. They stand on a roof of the shorter building. The students use a clinometer to measure the angle of elevation to the top of the taller building. The angle is 44 degrees. So I'm going to put that 44 degrees in the top triangle at the bottom on the left. So 44 degrees. And the angle of depression to the base of the taller building is 53 degrees. Okay, so go ahead and label your diagram. So we're looking essentially for the height of the shorter building and the height of the taller building. So I'm going to call them X and Y. Okay, so let's start with the shorter building. Okay, so if I know the angle outside of the triangle at the bottom is 53 degrees, if we subtract from 90, we can get the other missing angle. So 90 subtract 53, go ahead and figure that measure out, and we're going to put that at the top of the small triangle at the bottom. Okay, so that angle measure is 37 degrees. So now I have an adjacent and an opposite. Okay, so if our 37 is our perspective angle. So tan 37 equals 18 over x. Okay, let's go ahead and solve for x. So we're going to swap tan 37 and x and plug that into our calculator. Okay, so 18 divided by tan 37 degrees. Go ahead and plug that in. So we have 23.9 centimeters as the height of the shorter building. Okay, so the height of the shorter building is 23.9. Now we need to figure out the height of the taller building. So we know that from, let me just draw in a little squiggly line there. From that horizontal line that I drew into the bottom is 23.9. So we need to figure out what the missing piece up at the top is and then add them together to find the total height of the taller building. So we're basically looking for, I'll call it Z. Okay, so we have 44 degrees, we're looking for Z. We know the distance between the two buildings is 18 meters. So basically the new little triangle that we're looking at has 44 in the bottom, 18 is the adjacent, and Z is what we're looking for. So we're going to be using tan again. So tan 44 degrees, tan 44 degrees is equal to Z over 18. And we're going to go ahead and multiply by 18. Okay, so 18 times tan 44, go ahead and plug that in on your calculator. Okay, you should get 17.4 meters. Okay, now let's add them together. So 23.9 plus 17.4 will give me the total height of the taller building. Okay, so I was running out of space back there, so let's just use this other page here. So again, we're going to be adding 17.4 plus 23.9. Okay, so when I add them together, the total length is 41.3 meters. Okay, finally, we just need a concluding statement. Therefore, the height of the shorter building is 23.9 meters and the height of the taller building is 41.3 meters. Okay, go ahead and make your concluding statement. Okay, that's it for today. Thank you for your attention. See you next time. Bye-bye.